Hi everyone, welcome to questions on haloalkane mechanisms. So this first question is asking us that an alcohol is prepared from hydrolyzing the haloalkane, we've got the formula there for it, with aqueous sodium hydroxide. Need the mechanism, curly arrows, dipoles, all that good stuff. Now to start with, we just need to look at this formula we have here. Now this carbon, hopefully be able to identify that that is our sort of central carbon. We need to have it in a more of a sort of a displayed formula to clearly show what's going on with our curly arrows and our dipoles and things like that. We've got our sodium hydroxide, so that's going to be our OH minus with the lone pair on the oxygens. That's going to get started with that. So 3 marks, let's see what we can pick up. So, like I mentioned there is our central carbon that we had there. So hopefully when you read that formula at the top in the question, you can identify what that central carbon is, to then have something laid out so it's nice and easy to then show all your arrows and dipoles, etc. So what we have is the hydroxide, OH minus with the lone pair of electrons going to our carbon, which is slightly delta positive, and then we have our bromine, which is slightly delta negative, and then we have an arrow going from the bond between the carbon and the bromine to the bromine, so that's getting swapped out as it were. So in order to get marks here, we need the curly arrow from the hydroxide to the carbon, and then we need the dipoles and the curly arrow from the bond between the carbon and the bromine to the bromine. Those will get us 2 marks there. Now in terms of what's allowed, this is something we always spend time going through, is where we start and end our arrows from. So this is just showing you some examples of what would be accepted and what wouldn't be accepted. So you have to make sure that your arrow is starting from the right place. You can see there what is accepted, what isn't accepted. So from the lone pair, I've also got from the negative charge as well. But then still, you need to be careful as to where you're putting those negative charges or where your arrows are starting from the bonds. And then also as well from where your arrow's starting and where it's pointing to for that carbon to bromine bond. You've got those examples there to make sure it's so crystal clear, it's, you're not going to lose a mark for that. And then if we have our final product, we've swapped out our bromine for our OH, so therefore make sure you always add in that bromine or whatever it is that you've kicked out. Make sure you show that you have that there as well. So 3 marks there, 2 for your arrows and your charges and things like that, and then for your final product you get your final 3rd mark there. Okay, and final question we have here. Now we've got some sodium cyanide, so hopefully we've seen some reactions with that before. Increasing the length of the carbon chain. This is what we've got, nucleophilic substitution reaction. We've got to outline a mechanism for the reaction. Again, curly arrows, dipoles, and then also the structure that we need, 3 marks. So we've got 1-chloropropane, and then we've got our sodium cyanide reacting with it in nucleophilic substitution reaction. So this is what we have to begin with. Again, drawing things out, things are nice and clear. Again, we had sodium hydroxide, this time we've got sodium cyanide. Again, you notice how there's only a few different mechanisms that you need to know. Once you know one of them, if you know how they set up the format for a nucleophilic substitution mechanism, then it doesn't matter what they give you, same principle applies with all of them. So again, we have our Cn minus with a lone pair, curly arrow going to our carbon that's slightly delta positive, and the bond between the delta positive carbon and the delta negative chlorine, that bond goes to the chlorine. So again, making sure we have those in there. So there's 2 marks that we get for that bit there. And then our final product, we increase that carbon length. We now have a carbon to carbon bond that has then nitrogen on it. And then make sure we show that we have that chlorine, like we did the last one with bromine. Make sure we show that that's there as well. So you notice how there's a similar format with how these mechanisms work. If we know the few different mechanisms we need to know, then we can just apply our knowledge to that. Doesn't matter what they give us to start with, whatever reactants they want to give us, we're going to be okay for it. Okay, so that will do us today on reactions of haloalkanes mechanisms. See you next time.